Alright, continuing on with part 2. So here's what I came up with for my graph. If I look at this, I know that I'm going to go left 3 and then divide the x values by -1. And I know that this is base E, so I'm not really going to be able to plot a lot of points very accurately. A couple things I will be able to plot relatively accurately, though, is I know that normally every log function goes through the point 1, 0. So in this case, if I go to the left 3, I go 1, 2, 3 to the left, and then I divide that x value by -1, that's how I end up with x equals +2, 0. So that's how I get that point. The only other point I'm going to be able to do, which is not going to be very accurate, is I know 3 minus e is going to be where the y value is 1. 3 minus e is not going to be an easy number to plot, because remember e is like 2.7 something. So this value is actually going to be somewhere like right here. Sorry, I just had to adjust that. My domain, -infinity to 3, vertical asymptote x equals 3. X-intercept is 2, 0. We talked about that. Y-intercept is going to be 0, comma, natural log of 3. That's not a nice number. And again, here was my thought process and my work for how I can get x equals 2 as my x-intercept, or just the transformation idea that I talked about, that normally I know every log function goes to the point 1, 0, so I just transform that. Okay, one more example. So students in mathematics classes were given an exam and then retested monthly with an equivalent exam. The average scores for the class are given by the human memory model, where t is the time in months. So that's why it's 0 to 12. That makes sense. What is the average score on the original exam? What is the average score after 3 months? And what is the average score after 11 months? Pause the video, do that, unpause when you're ready to check. Okay, so here we should end up with the average score on the original exam was a 78. After 3 months, it's 67.765. And after 11 months, it is 59.654. So really all we're doing is plugging in those values for t. Keep in mind, since this just said log, we assume that that is the common log, so that's log base 10. So we can type that into our calculator. Alright, so we need to understand logs and how we get logs from exponential equations. They are inverses of each other. We have the same restrictions, plus this restriction on x. So y equals log base a of x, if and only if x equals a to the y. Again, that transformation from an exponential to a log and vice versa is the most important thing you need to know in this entire unit. We also really need to understand that a natural log is just like any other log. It's just natural, you know. It's kind of like free-range chickens in that sense. They're still just chickens. Don't overthink it.